Questions related to mutually perpendicular generators. So this is question number 1, and the same question is asked 4 times in 2020, 2015, 2008 and 2010 also. So let us see this question. So the question is, if this is a straight line representing one of the set of 3 mutually perpendicular generators of this cone, then we are supposed to find the equation of other 2 generators as well. So one of the line is basically x by 1 equals to y by 2 equals to z by 3, and one of the 3 mutually perpendicular generators, and equation of cone is 5yz minus 8zx minus 3xy is equals to 0. So let x by L equals to y by m equals to z by n be any arbitrary generator of cone. So if this I'm taking it as x minus 0, y minus 0 and z minus 0 as, because vertex of this cone is 0, 0 and any generator of the cone will be passing via the vertex. So I'm taking this as any arbitrary generator. So if this is mutually perpendicular to the given set of given straight lines, so from there I'll get L plus 2m plus 3n equals to 0. Also what I can do is, if this is any mutually perpendicular generator, I can equate it with equals to r. So any arbitrary point on generator will be basically LR, MR and NR. So if this is any arbitrary point on generator, then this point must also be lying on the equation of cone. So if that's the case, I'll just substitute the value of this coordinate in equation of cone. I'll get 5 into mr into nr minus 8 into nr into lr minus 3 into mr into lr equals to 0. And if I simplify it, I'll get 5mn minus 8ln minus 3ml equals to 0. Now I got basically 2 equations in L, M and N, and I can easily solve it to get the value of L, M and N, and which will basically give me the equation of generator which are mutually perpendicular to the given line. So from equation number 1, I get my L as minus of 2m plus 3n, and I'll just substitute this value in equation number 2. So from there I'll get 5mn minus 8n into minus 2m minus 3n minus 3m into minus 2m minus 3n equals to 0. So if I simplify it, I'll get 8mn plus 16mn plus 24n square plus 6m square plus 9mn equals to 0. On further simplifying it, I'll get 24n square plus 6m square plus 16 plus 9, 25 plus 5, 30mn equals to 0. I can divide throughout by 6. I'll get m square plus 4n square plus 5mn equals to 0, which is basically, I can write it as m square plus 4mn plus mn plus 4n square equals to 0. So I can solve it to get m into m plus 4n plus n into m plus 4n equals to 0, and from here I got m plus 4n into m plus n equals to 0, and from here I got m plus 4n equals to 0 or m plus n equals to 0. So we got 2 cases. So case 1 is when m plus 4n is equals to 0. So from here I'll get my m as minus of 4n and my L is basically minus of 2m plus 3n. So from here, by substituting value of m, I'll get my L as minus of 2m is minus 8n plus 3n, so which is equals to 5n. So my direction cosines are L by 5 equals to m by minus 4 equals to n by 1. Likewise, when my m is equals to minus n, I got my L as minus 2m plus 3n, so which is equals to minus m as minus 2n plus 3n, so L as minus n. So my equation direction cosine of that generator would be L by 1 equals to L by minus 1 equals to m by 1 and equals to n by 1. So my two generators that are mutually perpendicular to the given generator, that is x by L, y by x by 1 equals to y by 2 equals to z by 3, are x by 5 equals to y by minus 4 equals to n by 1 and x by minus 1 equals to y by minus 1 equals to n by 1. You can also verify these by just taking product of the direction cosines, and you will see that their sum will end up to 0. That let's just do that. 5 minus 4 to the 8 plus 3 into 1, so this is basically 0. Similarly, you can check for another one, which will be minus 1 minus 2 plus 3, which is 0 again, and you can check in between these two as well. So this is minus 5 plus 4 plus 1 equals to 0. So these two are basically the other two mutually perpendicular generators of set. So let's move on to next question. So the next question says that show that this cone has infinite set of 3 mutually perpendicular generators. If this is a generator belonging to one such set, find the other two. So first we are supposed to prove that this cone has infinite set of 3 mutually perpendicular generators, and we know that any cone with ax square plus by square plus cz square plus 2ux plus 2vy plus 2fx plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d equals to 0 has 3 mutually perpendicular generators if coefficient of x square plus coefficient of y square plus coefficient of z square adds up to 0, that is a plus b plus c equals to 0. So if we observe our cone that there is no term involving x square, y square and z square, so coefficient of x square plus y square plus z square is basically equals to 0 plus 0 plus 0, which is 0 only. So the given cone has infinite set of 3 mutually perpendicular generator. So further the question says that x by 1, y by 1 and z by 2 is one generator belonging to any one such set. So we are supposed to find the other two generators like we did in the previous question. So if you observe the cone, so the cone is 3yz minus 2zx minus 2xy equals to 0. So if you observe that the vertex of cone will be basically 0, 0, 0. You'll get this by if you equate it with f, x, y and z. This is basically a homogeneous equation, so you can solve fx by fy equals to 0, del fy del y equals to 0 and del fy del z equals to 0. So if you'll solve these three equations, you'll get the vertex as this. So any arbitrary generator of the cone will be basically x minus 0 by L, y minus 0 by M, and z minus 0 by N. So if this is one of the three mutually perpendicular generators of the set, so these two generators must be perpendicular. So using that, I'll get L plus M plus 2n equals to 0. Let's name this equation as 1. Further, if this is generator of cone, so any arbitrary point on generator, that is LR, MR, NR, must lie on equation of cone. This any arbitrary point of generator must satisfy equation of cone. So using that, I will get 3 into Mn minus 2 into NL minus 2 into Lm equals to 0. Now I can solve equation 1 and equation 2 to get values of L, M and N. So if I do so, using 1, I'll get my L as minus M minus 2N. Now I can just substitute value of L in equation 2. So I'll get 3Mn minus 2N into M plus 2N. This minus will balances out the 1 minus N. There, likewise 2M into M plus 2N equals to 0. So if I just club in coefficients, so I'll get Mn into 3 plus 2 plus 4 plus 4n square plus 2m square equals to 0. So I can further simplify it as 2m square plus 5 plus 4 9 mn plus 4n square equals to 0. So I got a relation in m and n, and I can just reduce it to a quadratic equation. So I'll get 2 of yeah, 4 to the 8, 3mn plus 2mn, 4 5 6 plus 3mn. Okay, so if we solve it, we'll get 2m square plus mn plus 8mn plus 4n square equals to 0. And I can write it as, I'll take m as common, so I'll get 2m plus n, and from here I'll take 4n as common, so 2m plus n equals to 0. So I'll get 2m plus n into m plus 4n equals to 0. So from here I'll get either 2m plus n is equals to 0 or m plus 4n is equals to 0. So there arises two cases. So case 1 is when 2m plus n equals to 0. So I got my n as minus 2m. So my L is minus m minus 2n minus m minus 2n, which is minus 2m. So L is 4 minus 1, 3m. So I got my direction cosine as L by 3 equals to m by 1 equals to n by minus 2. And when my m plus 4n is equals to 0, I get my m as minus 4n and my L is minus m minus 2n. So L is 4n minus 2n is equals to 2n. So I got my direction cosine as L by 2 is equals to m by minus 4 equals to n by 1. So these are the two equations. So equation of other two mutually perpendicular generators of the set are x by 3 equals to y by 1 equals to z by minus 2 and x by 2 equals to y by minus 4 equals to n by 1, and the given one is x by 1 y by 1, x by 1 equals to y by 1 equals to z by 2. You can just verify it. 3 into 1 plus 1 minus 4, which is 0. 2 minus 4 plus 2, which is again 0. And 6 minus 4 minus 2 is equals to 0. So these three are basically mutually perpendicular, and we have verified also. So these are only two distinct questions related to this topic that are asked. So thank you for watching.